Hi, welcome back to this channel. In this video, we are going to start with chapter 7, haloalkane. So first we need to draw the structure and then we need to classify the haloalkane. Another term for haloalkane is alkyl halides. Besides from draw and classify, we also need to name the haloalkanes. Then we are going to identify that why haloalkane consists of polar bond. Due to this character, haloalkane prefer undergo nucleophilic substitution. Tutorial question number 2. Draw the structural formula of the following compound. First, 1,2-dichloro, 3-isopropyl cyclopentane. So as usual, we identify the parent cyclopentane. 1,2-dichloro, 3-isopropyl. So this is the structure for question 2A. And then question 2B, third butyl chloride. So we have to draw third butyl, 1 carbon, and then bonded with 3 alkyl group, so that it will become third butyl, and then bonded to Cl. So this is the structure for third butyl chloride. So C, 2-butene. Butene is the parent, consists of 4 carbon. And then there is double bond because the name ends with ene, so means that there is double bond at the second carbon. 1,3-dibromo. So end up this one and still have another 2 hydrogen. This one still have 1 hydrogen. And this is CH3. So D, trans 2,3-dichloro but2-ene. So but2-ene also similar with 2-butene. So we're going to draw the structure, 4 carbon, and then butene will double bond will at the second carbon, and then 2,3-dichloro. But because of the question asks us to draw in a trans structure, so basically we know that we will have double bond, one bond bonded to chlorine, and then another carbon also bonded to chlorine opposite side, so that it can show trans. So this is the structure for D. Then the last structure is E, which we will going to 3-phenyl 1-hexene. So 1-hexene is the parent, so need to have 6 carbon. And then the double bond in between first and second carbon. So at the second carbon we have fluoromethyl. So methyl have 1 carbon. In between this methyl we will have 1 fluorine, so will become CH2F instead of CH3, and then 3-phenyl. So phenyl consists a benzene ring. Then now we can complete with the hydrogen, CH2. So here we have CH, CH2, CH2, and CH3. So these are the structure that we need to draw for question 2. Now let's proceed to question number 1. We need to classify the compound as primary, secondary, or tertiary haloalkane, and then we have to give the name based on the IUPAC name. Okay, so first we classify the haloalkane first. Basically, the way we classify haloalkane is quite similar with classify the carbon. So we only need to focus to the carbon which consists of bonded to halogen. So this is the carbon bonded to halogen. 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 So each carbon that bonded to halogen is highlighted with yellow color. So for the structure B, maybe I need to expand the structure, become CH2 double bond, CH, CH2, 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 Cl. Okay, so therefore the carbon that bonded to the carbon that bonded to hydrogen is to the halogen is this carbon, which we need to highlight as yellow color. Okay, so now we classify the carbon first. Classify the haloalkane. Due to the first carbon is bonded to this carbon is tertiary carbon. Therefore, this haloalkane will also consider as tertiary haloalkane. Okay, this carbon is primary carbon, so we'll consider as primary haloalkane. Same case to the structure structure C also primary haloalkane. Donkey also primary haloalkane. E, this carbon bonded to 1, 2, and 3, so it's tertiary haloalkane. This one is secondary haloalkane, and this one also considered as carbon 1, 2, so it's secondary haloalkane. And the last one is primary haloalkane. Okay, so now we are going to name the compound. Okay, so we follow the IUPAC system. So this is first carbon, second carbon, and third carbon. So it's propane. 2 methyl, we have methyl, and then also have bromo. So methyl and bromo come first. So it's 2 bromo, 2 methyl propane. Okay, structure B consists of double bond, and then first carbon, second carbon, third carbon, fourth carbon, and fifth carbon. So it's pentene. As we know, double bond, here we have double bond, 2 functional group, and another one is halogen. Halogen has the lowest priority. So in this case, we will give priority to carbon-carbon double bond. So we will name this as first carbon. So the answer for B, the name for B is 1-pentene. So and then the chlorine is attached to the fifth carbon. So will become 5-chloro 1-pentene. Then next one is structure C. Structure C is carbon 1, carbon 2, and carbon 3. However, in this case, we only have one functional group. So this carbon will consider that bonded to carbon and that bonded to fluorine will consider as carbon 1. So fluorine and methyl, fluorine come first. So the name will be 1-fluoro 2,2-dimethyl propane. Okay, structure D. So because again also only has one bromine, so maybe we try to make this one as the first carbon. So carbon 1, carbon 2, carbon 3, 4, 5, 6, and 7. Okay, however, if we do the numbering another way round, 1, 2, 3, 4, 5, 6, 7, 8. Green color here is considered as 8 carbon, which is longer than the red color 7 carbon. So that means we have to do the numbering based on D, because the first priority is select the longest carbon chain. Okay, so now I erase the numbering at here. Okay, then we go back to here. Carbon 1, carbon 2, carbon 3, carbon 4. Okay, 5, 6, 7, and 8. So we know this is octane. So octane is the parent. So at the fourth carbon here, we have methyl. So we will put 4. Sorry, not methyl, ethyl. But this is, if ethyl is CH2, CH3, but now here we have Br, so this one we'll consider as carbon 1, and then the carbon bonded to halogen is carbon 2. So that's why you have to make a bracket to show that 2-bromo ethyl octane. Next one we go to E. This one is a cyclopentane. So we have the parent name cyclopentane. So this definitely is carbon 1. So here is fluoro, and then 2 carbon is ethyl. So ethyl and fluoro, ethyl come first. So it's 1 ethyl, 1 fluoro, cyclopentane. 1 ethyl, 1 fluoro, cyclopentane. Next one, we can see there is a double bond, and then it's cyclic compound with 5 carbon. So will be known as cyclopentane. So since the double bond need to label as carbon 1 and carbon 2, so the anti-clockwise at the same time also will give the lowest number to chlorine. So will become 3-chlorocyclopentane. While for G, this one is a cyclohexane. And then this cyclohexane, so we have 2. Either is carbon 1 and carbon 2. Because of I come first, so normally we'll name this one as carbon 1, and then the methyl will become carbon 2. So 1 iodo, 2 methyl cyclohexane. So last one, as we already learned that this is a substitute, which we can note it as benzyl chloride. Okay, if you don't want to make it as benzyl chloride, then benzene will be the parent name, so it will be benzene. And then the substituent is methyl, but this methyl consists of 1 chlorine, so we will know this as chloromethylbenzene. Okay, in this slide, we will focus on the bond between carbon and halogen will be considered as polar bond because they have different electronegativity. And then we know that the halogen is more electronegative than carbon. So generally, haloalkane will consider as polar molecule. And then the carbon that bonded to halogen will known as alpha carbon. So this alpha carbon generally is lack of electron, okay, electron deficient. So and it will attract the nucleophile. So that's why generally haloalkane will undergo nucleophilic substitution. Okay, next part we will focus on the boiling point. Like just now we mentioned that because haloalkane is polar molecule. So if polar molecule, they will consist of dipole-dipole forces. So generally, the boiling point of haloalkane will higher than alkane and alkene, which where we know that alkane and alkene only consist of London forces. Dipole-dipole forces is stronger than London forces. So generally, we can know that haloalkane has higher boiling point than alkane and alkene. And second, Another conclusion is haloalkane will undergo nucleophilic substitution, which we will going to discuss further details in next video. Thank you and see you in next video. Bye bye.